Greetings to all the dear listeners present here. My name is Miss Lesline Sunny, Department of Commerce, the Bhopal School of Social Sciences. And today we are going to study a very important topic from Microeconomics, Unit 3, that is Indifference Curve. Before starting this session, let us see what are the learning objectives. After this session, you will be able to understand about the meaning of indifference curve. We will also discuss the definition of indifference curve by various authors, a discussion about schedule and diagram to understand the concept better, and at last we will also discuss about the properties of indifference curve. If we try to understand in simple terms what is indifference curve, it is a graphical representation of two various combination of goods about which a consumer is completely indifferent because it yields him the same level of satisfaction. To understand this concept better, let us look into the diagram. Assume that it is combination A and this is combination B. For combination A, we can see that there are more of bananas and less of apples. And for combination B, there are more of apples and less of banana. If there is a consumer and he has to decide which combination of good, that is A or B, he should have, he is going to be indifferent about it. The reason, because both will give him the same level of satisfaction. And if it is plotted in the form of graph, it becomes indifference curve. So, in short, I can say that indifference curve is a combination of two goods about which a consumer is completely indifferent because it will yield him the same level of utility. Now, let us look into the definition given by Ferguson. According to him, it is a combination of goods, each of which will yield the same level of utility, that is satisfaction, and the consumer is going to be completely indifferent about it. Now, let us see the schedule of the indifference curve. As discussed earlier, indifference curve has two combination of goods, as here it is apple and banana. If I talk about combination A, if a consumer takes combination A, he will have 1 unit of apple and 15 units of banana. And furthermore, if we look into this graph closely, it can be observed that a consumer is somehow ready to sacrifice the consumption of banana so that he can get an additional unit of apple. To express it mathematically, we can say that MRS is marginal rate of substitution, and it states that how a consumer is ready to sacrifice some of the goods so that he can get one more unit of that commodity. So, in this case, a consumer is ready to sacrifice more of banana so that he can get an additional unit of apple. To express mathematically, MRS is the change in sacrifice to the ratio of change in gain. So, let us try to find out MRS for each combination. For combination A, because we do not have a previous value, we cannot compare it. But if I talk about combination B, I can find out what is the ratio of sacrifice and what is the ratio of gain. 15 minus 10 is 5, and that is how much a consumer is ready to sacrifice banana so that he can get one more additional unit of apple. And that has been written here, that is 5 banana ratio 1 apple. For combination C, from 10 to 6, which means that there is a difference of 4. A consumer is ready to sacrifice 4 banana so that he can get an additional unit of apple. For combination D, 6 minus 3, which means a consumer is ready to sacrifice 3 banana so that he can get an additional unit of apple. And for the last combination, it is 2 bananas sacrificed so that an additional 1 unit of apple can be gained. If we look closely to the concept of MRS, you can see that the MRS keeps on decreasing. Why does this happen? This is because of the law of diminishing marginal utility, which states that as a consumer takes more and more units of a good, the satisfaction tends to decrease, and somehow he will try to get another commodity through which he can increase his utility. Now we will try to make a graph of this schedule to understand this concept in a better way. We will plot x-axis and y-axis. For x-axis we will take apple, and for y-axis we will take banana. We will plot the values 1, 2, 3, 4 and 5, and for y-axis we will go with the table of 3. Now we will try to plot this combination. For combination A, it is 1 apple and 15 banana. So I will plot it as combination A. For combination B, it is 2 apple and 2 apple and 10 banana. For combination C, it is 3 apple and 6 banana. For combination D, it is 4 apple and 3 banana, and for combination 5, it is 5 apple and 1 banana. So we can simply conclude here that whatever combination a consumer is going to have, it will give him the same level of satisfaction. And if we try to join these points, we will get a curve something like this, which is convex in shape. I hope that these concepts are clear to you. Now let us try to understand the properties of indifference curve. The first property of indifference curve is that it is convex to the origin. As discussed before, it is because of marginal rate of substitution which keeps on diminishing, and the reason is the law of diminishing marginal utility, which states that with every additional utility that the consumer is going to have, the satisfaction tends to decrease. The second property is that the indifference curve slopes downwards, that is from left to right. This is because of the reason that a consumer is ready to sacrifice more and more units of a good so that he can get an additional utility for another good. In the particular example, we had studied that a consumer is ready to sacrifice more of banana so that he can get an additional unit of apple. And because of this only, the shape comes convex in nature, moving downwards, that is from left to right. The third property is higher the indifference curve, higher is the level of satisfaction. So this is because of the assumption of monotonic preference, which means that a consumer will have more level of satisfaction when he is having a larger bundle. We will understand it with the help of example. In this graph, you can see that there is IC1 and IC2. Let us assume that for IC1, there are 10 apples and 20 bananas. For IC2, there are 20 apples and 40 bananas. We can see that it is the IC2 which is having a larger bundle. So it is assumed in indifference curve that the larger bundle will give the consumer higher level of satisfaction, and thus it is said higher is the IC curve, higher will be the level of satisfaction. The fourth property is that two indifference curves can never intersect each other. To understand this, let us revise what we had discussed just before now. We studied that higher is the indifference curve, higher will be the level of satisfaction. So, from this example, I can say that it is the indifference curve 2 which will yield higher satisfaction. Even if we try to intersect both these two curves, there is a point of intersection, which would mean here there is same level of satisfaction, which is not at all true, because two different IC curves have different level of satisfaction as well as different level of bundle. The fifth property of the IC curve is that two indifference curves can never intersect each other. Now let us understand this with the help of graph. As discussed earlier, x-axis represents apple and y-axis represents banana. If I try to draw a graph something like this, which is touching y-axis, it would mean that a consumer is consuming only one good, that is banana, and he is getting satisfaction from that, which is opposite of what we had studied, because we discussed that when I talk about indifference curve, there should be combination of two goods. In the similar way, if I draw a line or a curve through x-axis, it would mean that a consumer is only consuming apple, which is also wrong, and that is why no two IC curve can never touch either axis. I hope that these concepts have been clear to you. Thank you for your patience listening.